did post a quiz. It's quiz number 4, and it's due, I think it's due tonight. Yeah, a few people have turned it in, but please work on that quiz. It's only for, I think, 4 questions, maybe 5 questions. And even if you're like, if what you respond to on your answer is, I don't know what to do, I can give you a hint and then you can try the problem again. Just get started on it and then, you know, work towards having a score. For quiz number 4. For the homework, it's XYZ, and you're on homework number 7, also due tonight. And it's been a little busy lately, but soon I will try to update your Canvas gradebook so that you can know what your class grade is. But I just haven't had a chance to sit down and do that. So homework 8 will be due next week on Tuesday. And after that, we'll stop, review, and take a test. So we're talking about linear inequalities. In one variable. It can be written as AX plus B less than C. And A is not 0. Let's see. A, B, and C are real numbers. X is your variable, and A is not 0. And this symbol, the less than sign, can be switched. You can replace this with the greater than, less than or equal to, or greater than or equal to. So I put in quotes to help it stand out, but I mean, the symbol is inside the quotes. So it's greater than sign, less than or equal to. Or greater than. I'm gonna erase this, it looks like too much. So we're going to practice graphing inequalities. It's up to you to choose between dots, open and closed dots, or you pick brackets that are softer or square, but you don't mix them together. You either go with dots or you go with brackets. So you can use let's see. To graph an inequality, we're going to back up. So to graph a strict inequality, which would be one of the first two symbols I talked about. This one, strictly greater than, strictly less than. Okay. Use open circles. Or parentheses. And these open circles and parentheses will go on our endpoints, but we'll kind of practice that soon. Let me see. Okay, it looks okay. So then if we're talking about when you have greater than or equal to and less than or equal to, use a closed circle or a square bracket. So again, I mean, your homework kind of helps you with this because it's online homework, but you either go with open or closed circles, or you pick brackets and parentheses. You don't mix them together. And then you kind of place these over the endpoints, which we'll talk about finding, and shade over the solution section. So shade over values of the variable that make the inequality true. Okay, so the solution section, that's the place where you have those values of your variable that make your statement true. And what we can do is just split up our number line into intervals, pick a test point from each one, And that kind of helps us know where to shade. So I'll try to talk about using test points to shade the right section. Okay. We're going to start with graphing x greater than or equal to 7. Okay, there's only one variable, that one, x. So you only need one number line. Just usually we go with horizontal. But when we had a line, there were values for x and y, so you needed 2 number lines, but there's only this x variable. So this is all I need to draw. I like to put a placeholder for 0, but you don't have to. It's just as a place where I know this way is negative and this way is positive. Towards positive infinity, we're going to mark 7. And then that's what I would call maybe a critical number or important value. And from that value, I'm going to go with a closed circle based on that equal sign in the symbol. Okay, that marker splits this number line from 7 down to negative infinity and 7 up to positive infinity. So on this side, you pick any value to test. If it's true, shade over that. If it's false, don't shade that side. Same thing here. You can pick a test point. If it's true, then it is a solution. You shade that way. If it's false, it's not a solution, and that's not the solution section. I'm going to write this all down. Kind of making these steps up from my experience. So usually you want to look at your inequality and solve for your variable. Which this one's already solved for. We have x isolated and everything else is on the other side of the symbol. Then use critical numbers to break the number line into test intervals. Break or split up or something like that. Okay, so I've already done this. I split the number line down where we have that number 7, my critical number. So this is just like a number that's like part of your inequality after you've solved for that variable. Okay, pick a test point. Or test points, choose test points in those intervals. So this is a little bit more for this last part. So you're going to have the test come out true or false. If it's true, shade that side. If it's false, do not shade that side. This is just if you're really having trouble finding your solution section, but maybe you have a little more practice and kind of know where to shade. If not, though, just pick a test point, test it. If it's true, then you shade that area. If it's false, don't shade that area, and then try another section, test that section. Okay, so like this one. I think an easy number to test would be 0. Let's put 0 into your inequality. You'd have 0 greater than or equal to 7. Which would be false. 7 is greater than 0. So this one's false. We're not going to shade over 0. I'm not going to shade any of the numbers below 7. So now I'm going to test some number above 7, like let's pick 9. That's kind of messy, but overall, this is like the number line is the graph. We'll kind of erase all the scratch work after. Okay. 9 in your inequality, 9 greater than or equal to 7, which is true. So this is one solution, and all of the numbers past 7 are also solutions. You're going to shade that whole interval from 7 up to infinity. All right, so we're going to graph -2 less than x less than or equal to 4. Okay, your variable is already isolated. So if step 1 is solve the variable. Step 2, use critical numbers like -2 and +4. Put those numbers on a number line. Above -2, we're using a closed circle based on this symbol right here. There's an equal sign in there. It's a solid dot. That symbol is open above 4. So on this side, you can include -2, and let's see, you can include -2. For that part, we're not including 4. Number's very, very close to 4, but not actually the number 4. Okay, break this into intervals. One goes from -infinity to -2, then you're going from -2 to 4, and then 4 and over. So you could pick a test point here, a test point there, and a test point there, and then know like which piece to shade. Okay, so I'm going to go through testing each section. I'm going to pick a number less than -2, like -5. And then put this in for x. It's -2 less than or equal to -5. Is that less than 4? So this is an and statement where if any piece of this is false, the whole thing is false. So even though -5 is less than 4, that is true, but -2 less than or equal to -5 is false. We're not going to shade below -2. Next, let's test 0. -2 less than or equal to 0. Less than 4. This part is true. This part also true. So if this whole statement is true, I can shade over that section. Extra shading. Now I want to pick any number past 4 to test, and then I can be done. So I'm just going to try 5. So we're putting -2 less than or equal to 5. Is that less than 4? So even though this part is true, this part is false. The solutions make the whole statement true. So this statement would be false. And you know that you're not going to shade any values past 4. And also you can erase this part where I split up the number line. We've gotten the solution section. We're going to do one more like this and then talk about interval notation. So I'm just thinking there are a few problems that have the word or as part of the whole expression. I think we'll get to examples like that later, but I'm going to keep it kind of simple for now. And just put x less than 5. Okay, when there's one variable, you just need one number line for that variable. And I mean, the only number you need to label is 5, but it's just my style to put 0 down and then kind of work from 0 a little bit over towards positive infinity, label 5. 5 is my critical number. That splits this number line into 2 sections. This section, where we pick a test point, and that section, we'll test a point. Let's go ahead and test. You can test 0, you can test any negative number, or let's test x equals 1. Put that into your statement or inequality. 1 less than 5 is true. So this is a solution, and all values this way are solutions, and your symbol does not have an equal sign in it, so your circle is open, and we can shade this way. And then just to be sure, we're going to test a number greater than 5, like we'll try 7, and see if we need to shade that side or not. Okay, 7 less than 5 would be false. So right here at 7, this is not a solution. I don't want to shade over that point. I don't want to shade any of these numbers on this side of side. Right. Let's talk about interval notation. Okay, let's see. Okay. Intervals are written with rectangular brackets or parentheses. And 2 numbers that are called endpoints. And they're the endpoints of the interval. Okay, the smaller number or value always goes on the left. So let's say your set is from 8 to infinity. You would want that 8 on the left side because it's smaller than infinity, instead of having infinity first and then 8 after. So small number goes on the left. Or if part of your interval is negative infinity, then it definitely goes on the left because it's like the smallest value you can have. So on that note, plus and minus infinity always has parentheses on it. That's actually about including your ends or not. So to include the ends, use rectangular brackets. or square brackets, the same thing. We'll put square. Use parentheses for endpoints that are not included. DHES. Yes. Okay. And this is where I was trying to mention positive and negative infinity are never numbers you can include. So they always have parentheses. Something simple. We're going to graph the solution section and write the solution set in integral notation. We're just going to put graph. We're graphing x greater than 2. And writing the solution set. In interval notation. Okay, starting with a graph, just one number line for that one variable. And we need to place 2 on our graph. And we want to find the solution section. So I could split this. Test a number less than 2. And we're going to test a number greater than 2. And also going to that symbol is a strict inequality, which means I have an open circle. All right, let's test 1. Okay, is 1 greater than 2? Nope, that's false. So we're not going to shade this side. Do not shade. A number greater than 2, like positive 3. Okay, 3 greater than 2, that's true. So this is a solution, and all of the numbers greater than 2 are also solutions. Actually, all the numbers from 2 over to positive infinity are solutions. I'm going to shade over that section. And then this open circle means you can have a number very, 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 very close to 2, but do not include 2. Like you could have 2.000001, but not actually the number 2. Okay, the solution set. Goes from the small number over to the larger number. The smallest number you can have is 2. You can't actually use the number 2, so use a parenthesis, which means get very close to 2, but don't include it. Then the larger value would be positive infinity. And this always has parentheses. So it's not a number that you can include in the set. All right. Do one more example, and then there are, I think, 2 rules. No, we're going to do the rules first, and then examples using those rules. So actually it's called a property. It's the addition property. For inequalities. If A is less than B, and A and B can be numbers, or they can be algebraic expressions, anything of this form. Then you can add the same value to both sides. Okay, we want to practice solving an inequality. So we're finding the solutions, we're finding the values of the variable that make the inequality true. It's 6x plus 6. Less than or equal to 4x minus 2. So also we've mentioned that when you solve for a variable, you want to isolate that variable, have it on one side of your symbol, which is an equality sign. Everything anything else on the other side. So maybe subtract 4x from each side. Make sure you copy down the same symbol less than or equal to. And then this would be 2x 6 less than or equal to -2. So then I would subtract 6 from each side. Keep trying to isolate x. Again, copy down the same exact symbol. And now this side has 2x less than or equal to -8. And then this is where I need to introduce our other property. So what we want to do is divide those sides by 2. And then we'll write down where that property comes from next. So divide by 2 on each end. I got x less than or equal to -4. So what we have done is found the solutions and written that algebraically. Another way to express the solutions is with our graph, which let's do a quick sketch. We have a number line for x. We need to label -4. And then test points, like you could test 0, just 0. Negative, let's do -10. I'm going to include -4. Put 0 right here. Zero less than or equal to -4, which is false. So I'm not shading this way. I think I'm going to shade this way, but I'll test -10 just to be sure. So putting -10 into my inequality. Is it less than or equal to -4? It is less than -4. It's true. So from here, I do want to shade over that solution, and all of these values are solutions as well. Again, you have your answer written algebraically. You can write it graphically, or you could write it as a set, and we put those sets in interval notation. Is going to go from the smaller value, which this time is -infinity, which always has parentheses on it, over to the larger number of -4. You can include -4, so it needs a square bracket or a hard bracket. Okay, and then another property. The multiplication property for inequalities. this has two parts. The first part I already kind of used, and it's when you multiply or divide by positive numbers. So let's split this up. Part one. If C is greater than 0. So C is a positive number or positive algebraic expression. Then A is less than you can multiply both sides by that positive number and keep the sign just the same. So you have A times C, keep the sign, less than B times C. And that's for multiplying and dividing. So when I divided both sides by positive 2, I copied the symbol down and did the same thing to both sides. Multiplied both sides by 2 or divided both sides by 2. Okay, the second part. When C is negative, so if C is less than 0, and you have A less than B, then for negative numbers, if you multiply both sides by that number, you have to flip the sign. So AC would be greater than BC. If you ever multiply or divide by negative numbers, you have to flip the sign. Okay, let's do an example. So negative 3x plus 1, and it's less than or equal to 7. Okay, so you want to start to isolate x, and then use the first property, subtract 1 from each side. It's one way to start. For this property, you just copy down the symbol. This would be a 6. And here is negative 3x. Okay, now what I want to do is divide both sides by -3. If you ever multiply or divide by a negative number, you have to flip the sign. So flip this around. Here. This is -2. And here we've gotten x. All right, while we're here, let's draw this graph and find the solution set. Only one variable, x. So we just do one number line for the variable. We want to label -2. And we're going to either shade below -2 or above -2. Back to this inequality sign, you are going to include that number. Solid circle. Is -10 greater than or equal to -2? That's not the solution section. Let's try +10. Greater than or equal to -2. Go this way. Positive. So we're looking at the set of solutions in the interval notation. Going from your smaller number on the left, larger number on the right, start at -2 and include that with a square bracket. Go over to positive infinity, which always is going to have a parenthesis. Great, and now for the rest of the class is just doing examples using our properties. So it's -1/2. 8x plus 10. And then subtract 2x. So less than x. Okay, so it's kind of like a little bit similar to when we have an equation. You want to distribute and expand everything out, then bring it back by combining like terms, and then start to isolate your variable to one side of your symbol. Okay, so you want to distribute this -1/2 and start to expand the left side. -1/2 times 8x be -4x. -1/2 times +10 is a -5. Over here with the -2x. Then you want to put your like terms together. x values. Negative 4x and negative 2x is negative 6x. I think what I did next was just add 5 to both sides. So we have negative 6x is less than x plus 5. And I subtracted x from each sign to get just one value of that variable. Negative 7x less than 5. Okay, so right now, all I'm doing is going to copy this down exactly how it is. What I want to do is divide both sides by negative 7. But if I divide by a negative number, I have to flip the sign. It's negative 7, negative 7. Here, I'm going to flip. This is positive x. It's greater than negative 5/7. And I do want to do a quick graph and write the solution set. So number 9 for that variable. Negative 5/7 would be, since it's negative, it's just a little below wherever 0 is. I'll put 0 down just to help me visualize. But really, I just need to test below negative 5/7 and above negative 5/7. And also, we're looking at a strict inequality, so there's an open circle right here. Okay, I'm going to test 0. If I have x equal to 0, then we're putting a 0 greater than negative 5/7. Or I could go back to the very beginning, the very original inequality, but I trust that I've solved it correctly. So I'm going to use this simplified version. I put 0 in for x. 0 greater than a negative number is false. Wait, no, that's true. I'm sorry. True, very true. 0 is greater than negative numbers. So I do want to shade that way towards 0. I could test another negative number like negative 10. Negative 10 greater than negative 5/7. Let's see. Mhm. Okay, so this is like about negative 0.7, and this would be negative 10. Negative 10 is much more negative than negative 0.7. So it would be less than that number. So this is false. So only shading on this side. And your interval starts at the smallest value in the set, negative 5/7, goes towards the larger value, which would be positive. So from negative 5/7, and we don't include that number, so use a parenthesis, up to positive infinity, which always has parenthesis. Okay, so there's three ways to answer the question. There's an algebraic statement, there's a graph, and there's a set. And usually the set is in interval notation. Solve and graph. Four minus 1/2 x. And it says less than 2/3 x minus 5. Okay, so first of all, you can notice there's fractions. Fractions can be a little messy to work with, so you can use a trick we've had before, where to clear the fractions, multiply both sides by the LCD. And just be careful, I would use a positive number to clear the fractions, so that way you don't have to worry about flipping the sign. Here our LCD is made up from our denominators. One of the factors in the denominator is 2. There's another factor of 3. Take all, the most if you have of any factor, which is one of each of them, multiply together, and you got 6. So I'm going to multiply both sides of the inequality by 6. Six multiplied with 4 minus 1/2 x. And it's less than, oops, just less than. The 2/3 x minus 5, and then multiply that with 6. Okay, on this side, you just distribute 6. 24 minus 3x. Okay, and on this other side, 6 times 2/3. 6 divided by 3 would leave a 2, and that 2 times that 2 is going to be a 4x. And then 6 times negative 5, minus 30. Okay, let's get these x values together by adding 3x to each side. Copy this symbol down. And this would be 7x. Over here is just 24. Cool. After that, I would add 30 to each side. So we've got 54 less than 7x. We're going to divide both sides by a positive 7, so you don't have to flip the sign. It's only for dividing by negative numbers. It's positive, just copy the sign. This is x. This would be, well, you left it as 54 over 7. Which is about 7.7. I'm just going to be using this to help me draw the graph. So we're going to start with the number line over x. 54 over 7 on the map. And check out our symbol. It's strict, so there's an open circle. And then I want to test just a number greater than this value. Like, let's go with 20. So if x is 20, is 20 greater than 7.7? Yes. True. It would shade towards that number. Any negative number is a good test. So let's put -2. This is positive fraction less than -2. False. I don't want to shade this way. It's only this side that's the solution side. Let's go ahead and put this in interval notation. So this would be like your algebraic statement. This is your graph. And the last part we talk about is the solution written as a set. The solutions written in a set. The set starts with a smaller number on the left, which would be 54 over 7. You don't include that number, so use a parenthesis. Go over towards positive infinity. It also always has parentheses. I think we're done. Oh, right. So that's the end of the notes. Next time, we need to talk about absolute values. but then we'll also have absolute values with inequalities and do more of this kind of practice. So please get started on your homework. And I'll see you Thursday.